Hi guys, Josh from Lucas Lighting, and today is the final video of the Decoder series version 1. I say version 1 because you never know, we might come out with different versions of this later, and I'll have to shoot another series. To recap, we've talked about capacitance, how it solves flashing or flickering or pulse width modulation, digital variable resistance, where essentially we're controlling current, reverse polarity correction, and allows LEDs to work in series. Let's get to it. Okay, the very first thing I want to talk about is voltage and capacitance. So you learned from the first video that we have capacitance on board, and basically if you have voltage ripple or some kind of voltage issues, typically this ripple is going to be below the 12 volt line, and then if you have pulse width modulation going on, you're going to be going from 12 volts to 0. So the output of the decoder, if the input's 12 volts, but it's a dirty 12 volts, the capacitor is going to kind of average that up a little bit, which is going to pull your voltage slightly down on the output side, and I can demonstrate that. We're going to be looking for a clean output, which the capacitor is going to give us, but the voltage will be slightly lower. I can demonstrate that very quickly. So I've got a power supply here. It's 12 volts. We're outputting through a decoder to an L5 bulb. If you look at my multimeter screen right here, I've got roughly 12 volts there, but on the output side of the decoder you can see that we are down to 10.4 volts. So from 12 to 10.4, definitely a voltage drop there, right? Okay, so here's what happens is a lot of times, almost 100% of the time, this is what your light bulbs look like in your car. Your headlight left and right, they both have their own ground path, they both have their own power path, right? So these bulbs are both getting 12 volts solid, right? Okay, but in a daytime running light situation like a lot of Toyotas have, the bulbs are in a series connection. So what happens is, whether this is 12 or 14 volts when the car's running, each bulb is going to get 6 to 7 volts each. Okay, now the problem with that is if we plug this in, put it on the power supply, and we bring the voltage down, as soon as we go down to 7 volts, I mean, we're barely illuminated, right? You go down to 6 volts, you have no illumination at all, okay? These really need 8 volts at least to run, to have any kind of brightness at all, even a daytime running light type of brightness. So if you put a decoder in here and you're already at 6 volts, you're now at 5 volts. So in that situation, a decoder is not going to do anything for you. So if you test your bulb socket and your bulb socket is 6 volts, the decoder is not going to do anything for you. I have a video coming out later this week that will give you all of your options for these situations. There are a couple of different options. Decoders are not going to help you in that situation. When we list that decoders allow LEDs to work in series, we're really talking about 24 volt systems. So it's not something that we typically advertise, I suppose, but it is. They do help you in a 24 volt system if you have series bulbs, but it's something you're never really gonna see that or use that. So it's worth mentioning. I will have solutions for series bulbs for you in a video that we'll post later this week. The very last thing I want to talk about is H2L. I get this question a lot. Do I need decoders for H2L? The answer is always no. These are a plug and play closed system. They plug right into the 85 volt ballast output of your car. You never need decoders on these, okay? But if your ballast for some reason isn't working and you need to hardwire a kit, we do have 2 hardwire kits. One is the L2D series, and there's the part number for you, and the other one is the L3D series. Now the L3D series is pretty bright, so a lot of people will just put the L3 in anyway and bypass their ballast. And what that kit looks like is this. It's an L3 bulb. It's got a D series collar, goes right in. You got to mount it up. You're going to have a pigtail right here, which it comes with, and this is just going to wire into your 12 volt supply from your ballast, okay? So sometimes when you do that, if you defeat the ballast, you need a decoder right here because you'll get a bulb out error. So essentially, wire this guy in. If you don't have any bulb out errors, great. if you do have a bulb out error, this is a 9005-6 disconnect. So these all require 9005-6 decoders if you have a bulb out error of any type. So look forward to next week. We've got series solutions for you. One thing worth mentioning on this in terms of the voltage drop is the new GM vehicles, mainly their trucks, some of their headlights are ran on an integrated circuit. So they'll take the factory halogen bulb and they're basically upping the voltage to like 15.5 volts to make this thing, look brighter, which of course prolongs, it defeats the life of the bulb by a great deal. Our L2 to L5 bulbs, sometimes that will kick them into 24 volt mode. So they're in 24 volt mode, running 15.5 volts, which is not good. So what this will do is this will knock that down to a manageable 14 volts or 12 volts. And so then those will run on 12 volt mode with this in a GM. So worth mentioning that GM vehicles will definitely reduce the life of our bulbs without a decoder. So they'll work, but it'll reduce the life of the bulb. So if you have any questions, I will have the tech support info up next, and I appreciate you watching. Look forward to next week where we will talk about series and parallel circuits with LED bulbs.